that the answer?
Okay,
I
so
actually,
we're gonna talk about this problem, okay, without doing any calculations. Okay. So
I think I might have the answer.
okay,
Those
so
are actually square numbers. I can't believe it.
basically you have a
What?
rhombus with diagonal root 31 and another diagonal root 21. And that determines the rhombus, yeah? And we actually so we know the side length of the rhombus and we know the um the angle of the rhombus, yeah? And so we know a lot about the rhombus. For example, you can get the sine of the angle by just doing the area of the rhombus, yeah? So you know the sine of it. So if we label the rhombus um like the small angle
Okay.
little gamma and the big angle capital gamma, yeah? Then we know for example we know sine gamma is equal to sine
I hope I'm
capital
not tripping.
sorry sine capital
I
gamma,
really
yeah?
hope I'm not tripping.
Why did I write a mega? Okay.
If I'm tripping balls that have sex, that's surely not.
Okay. Sine capital gamma. Okay. Because sine of 180
Okay,
minus
tell
angle
me
is equal
what
to
you
sine.
guys get for the
Yeah.
answer when you're
So
wrong.
these are parallel, so these angles add up
I
to
got
180.
it wrong
Yeah.
and I'm sad.
Okay. So we know those things from the area. You know the area formula is like half AB sine C. Yeah. So you can do that with the rhombus. You know that, and then you also know the side length x. Okay. And then the question is, how, so okay, so we're not going to prove how to put them together in like all the different ways, but we're just trying to find two ways and find the ratio of the volumes. Okay. So one way you can do it is basically you can make sure all the little gammas are at the corner. Okay. And the other way you can do it is you make sure all the big gammas are at the corner. Okay. And I guess it sort of goes with that. Like in the end, if the volumes are different, then you know they're not congruent, right? So it's kind of self-fulfilling. So um okay, so then the volumes only depend on the height of the parallelogram. Yeah. Okay. And we're claiming that the height of the parallelogram is the ratio of the heights, okay, is given by sort of like sine, it's like theta or alpha on sine beta, okay, where alpha and beta are determined by these conditions. So cos gamma equals cos alpha cos gamma on 2 and cos gamma equals cos beta cos gamma on 2. Does that make sense? Alright, so once we have those conditions, the rest is just calculation. Okay, so for example, if you know sine alpha, yeah, sorry, if you know cos gamma, we said we know cos sine gamma, yeah. If you know sine gamma, then you know cos gamma because sine squared plus cos squared is 1, yeah.
Yeah.
Okay, and if you know cos gamma, right, then you know cos gamma on 2 because the double angle formula is 2 cos squared gamma on 2 minus 1. Yeah. Okay. So if you got that, then we've solved the problem up to calculation. Okay. Okay. And then how do you get those conditions on alpha and beta? Okay. And how do you get that the area, the height depends on sine alpha? Well, so what we're doing, but literally we're just making like we're assuming that the third vector is on this angle bisector plane, which is perpendicular to the base. Yeah. Okay.
Alright.
And we're saying it makes an angle of alpha, or in this case, alpha or beta, with that angle bisect. Okay. So then obviously, if it makes an angle of alpha, then the height will be x sine alpha, right? Like this height. Yeah.
Okay, let me do it.
If it makes an angle of beta, it'll have x sine beta, right? So therefore, the ratio of the heights is just sine alpha on sine beta. Yeah. Okay. And then the question is like, why is sine alpha and sine beta determined by those conditions, right? So the way we got it was we found coordinates for basically so we made up coordinates for these three vectors. And we took the dot product. So basically as alpha varies, the angle the third vector makes with the first two changes, right? And so we want to vary it so that it makes exactly the gamma angle with the other two vectors, right? So then we just put it into an expression where the angle is. So one expression is like if this is like u and this is v and that's w, then we know that u dot w equals x squared cos gamma. It's like the dot product thing, okay? And then obviously when you got the coordinates of u and v and w in terms of cos theta, sine theta, x, and gamma, you'll see these are the conditions that you get. That makes sense? So, for example, if you do it Alex's symmetric way, you put u and v on the xy plane, right?
Yeah.
You make the angle bisected the x-axis, yeah? Then v will be like x cos gamma on 2, x sine gamma on 2, 0, yeah? Okay. And so if you dot that with w, and w will be, so this w will be easy now because w will be just cos theta 0 to x cos theta x sine theta. Yeah. Because it's literally on the x-axis. So it has y value 0. And it makes an angle of theta, so it literally is x sine theta up and x cos theta across. Yeah. So then when you dot them together, you get x squared cos theta cos gamma on 2, right? And so x squared cos theta on 2 equals that thing. So it's maybe not theta, but alpha. Or alpha or beta, yeah. And then cos gamma on 2. So then the x squareds cancel. And you get cos gamma equals cos alpha or beta cos gamma on 2. Yeah? Okay, so that's the calculationless version. Okay, and then the actual calculations, you might want to find what cos gamma and cos gamma on 2 are, starting from sine gamma and sine gamma. Yeah? Any questions?
Oh yeah.